good day, classmates. So for today's task, I'm going to prove the integral. So I am Maria Isabel Emeliorca, a second-year student in the BSM Math program at the University of Southeastern Philippines, Tagum Unit. So here with me are the list of the integrals that we are going to prove today. So we have the first one is the integral of u multiplied to e raised to the power of u du equals to e raised to the power of u multiplied to the quantity of u minus 1 plus c. The second one is the integral of the square root of a squared minus u squared all over the u squared du equals to negative square root of a squared minus u squared over u minus the arc sine of u over a plus c. Okay, for the third one, we have the arcotangent u du equals to u multiplied to arcotangent u plus 1 half ln of the absolute value of 1 plus u squared plus c. So let us try to prove now the first one. So we have we're going to prove that the integral of u multiplied to e raised to the power of u du equals to the e raised to the power of u multiplied to the quantity of u minus 1 plus c. So here is the solution. Okay. So for this problem, we're going to apply the integration by parts. So if you already know the integration by parts, the integration of the function equals to u times b minus the integral of v du. So for this problem, we're going to let u be equals to u, and the derivative of u is du, of course, and we have the b prime is e raised to the power of u, then our v is u. So we already have the u, v, and v also, and the du, so we can substitute na. So this would be the next step. So the integral of u multiplied e raised to the power of u du is equals to u times e raised to the power of u, which is the u and the v, minus the integral of the b. What is the integral of the v? Is eu right here. So we have the integral of the b multiplied to du. So by simplifying na lang, multiplied. So u times e raised to the power of u. We have u e raised to the power of u minus the e raised to the power of u times 1. Of course, we're going to have the e raised to the power of u du. So for this one, we can apply the integration to e raised to the power of u du. So the integration of the e raised to the power of u du is, of course, the e raised to the power of u. So for the next step is that, as you can see from the last, this one, we can simplify it. So it will become e raised to the power of u multiplied to the quantity of u minus 1 plus c. So from this one, na answer natin is the same from this one. So we can claim, or we can conclude na therefore that the integral of u multiplied to e raised to the power of u du equals to e raised to the power of u multiplied to the quantity u minus 1 plus c is true. So for the next one, this one is much complex compared to the first one. So we're going to prove that the integral of the square root of a squared minus u squared all over u squared du equals to negative square root a squared minus u squared all over u minus the arc sine of the quantity of u over a plus c. So in order to prove this one, what we're going to do again is to solve the integral. So for the solution, of course, we're going still to apply the integration by parts. So we have the u, we're going to find u, v, and du, of course. And then we're going to let the u be equals to a squared minus u squared, the square root of it. So as you can see, the u, to derive the u, we can use the chain rule for this one. So we're going to let x be equal to a squared minus u squared. So the dx of it is 2a 2u, if I'm not mistaken, negative 2u. So here, so for this one, from this, we derive the square root of x. So the derivative of the square root of x is equal to 1 over 2 square root of x multiplied to the derivative of the inner function. We have the a squared minus u squared, which is negative 2. As you can see here from below, no, that the negative 2 and 2 can be simplified. So, in simplification of this, we can obtain that the du equals to negative u square root of x. So, from this one, we can substitute back the x equals to a squared from here. Here na siya. Minus u squared. So, the derivative of the u of a squared, the square root of a squared minus u squared, is negative u all over the square root of a squared minus u squared du. So, we already have the u and the du. Next, we're going to have the v. Okay, for the v prime, we have the 1 over u squared. So, what is the v from this one? V is equals to u raised to the power of negative 2 plus 1 all over negative 2 plus 1. So, negative 2 plus 1 is, of course, u negative 1 all over negative 1. So, our b here is negative 1 over u. So, for the recap, we already have the u equals to square root of a squared minus u squared. The du, we have the negative u all over the square root of a squared minus u squared du. And the letter v equals to negative 1 over u. So, from this one, we can apply the integration by parts na, no? Okay, let's review. So, here are the u, du, and the v. So, applying the integration by parts, we can have the integral of the square root of a squared minus u squared all over u squared du equals to u times b minus integral of v du. So, substituting the u, we have the square root of a squared minus u squared multiplied to v, which is negative 1 over u right here. And minus the integral of the b, which is the v is negative 1 over u, and multiplied to du, which is the negative u all over the square root of a squared minus u du. So, simplify nato ni siya. So, daghang negatives. So, by simplify nato ni siya, we can have, if we're going to simplify this one, so, multiplied. So, the positive times negative is negative, of course. So, a square root of a squared minus u squared all over u minus, since negative 1 over u times negative of this part of the du can have a positive. So, we have the negative sign all over here. So, bring down the negative sign. So, we simplify this one. We can cancel out the u right here. If you already know the rules, no? So, 1 all over the square root of a squared minus u squared du. So, from this one, we're going to apply again the integration from this. What we're going to use right now is the trigonometric substitution. So, from this one, we let the u be equals to a sine v. So, if we rewrite, the v would equal to arc sine of u all over a. So, we derive the u. So, the derivative of u is a cos b dv. Are you with me? Okay, good. So, from this one, we i-apply na to tong mga, we substitute na to si u and si du. So, sa our function. So, the integral of 1 all over the square root of a squared minus u squared du is equal to the integral of 1 all over the square root of a squared minus, we substituted the u right here from the thing that we let, no? So, it is a sine v squared, and the du equals a cos v dv. So, we simplify this one. This is very easy lang. So, the integral of a cos v dv from this one, we put that to the numerator, and then for the denominator, we distributed the squared to our function, no? So, square root of a squared minus a squared sine squared v. So, after that, we simplify since we can factor out the a squared from here. So it can be written as equals to the integral of the remainder numerator, a cos v dv all over the square root of a squared. Since we factor out the a squared, we have 1 minus sine squared v. From, as you can observe right here, it is a Pythagorean identity. The Pythagorean identity that we can use right here is the cos squared v equals 1 minus sine squared v. So, from this function, we can rewrite it into simpler function, which is the integral of the a cos v dv all over a, since we factor out right here the a, no? If you, as you can see from the difference from here and right here, the square root of a squared is equals to a. So, and the 1 minus sine squared is equal to cos squared v. So what is the square root of cos squared v is cos, no? So we can simply divide cos v to cos v. No, cos v all over cos v, a cos v right here, all over a cos v. So we can have the integral of 1 dv. So this is very easy. What is the integral of 1? The integral of 1 is v. So the letter v, we can substitute back the thing that we let from the thing that we did earlier, no? So what is the v natin? The v is equals to the arc sine of u all over a plus c. So we already solved this one, no? This integral of v dv, no? So we substitute it na. So thus the integral of 1 all over the square root of a squared minus u squared du is arc sine u over a plus c. So therefore, the integral of the square root of a squared minus u squared all over u squared du equals to negative, from this one, the simplified u times b, if I'm not mistaken. We're not mistaken, of course. So square root of a squared minus u squared all over u minus the integral of 1 all over the square root of a squared minus u squared du. So what is again the integral of 1 all over the square root of a squared minus u squared du? It is the arc sine of u all over a plus c. So we write this one, no? So equals to negative square root of a squared minus u squared over u minus the arc sine of u over a plus c. From this one, we can therefore conclude that the integral of the a squared minus u squared all over u squared du equals to the negative of the square root of a squared minus u squared all over u minus the arc sine of u plus a plus c is true. So you can see here they're similar. Therefore, the item number 2 is proven to be true by integration. So for the third one, we have to prove the integral of arc cotangent u du equals to u multiplied the arc cotangent u plus ln of the quantity of the absolute value of 1 plus u squared plus c. So to solve this one, we're going to have the solution first, a copy. So for this one, we're still going to apply the integration by parts, which is the u times b minus the integral of v du. So for this one, we're going to let the u be equals to arc cotangent u. So the derivative of arc cotangent u equals to negative 1 over 1 plus u squared du. Okay, so for the b prime, we have the du. So for v, we have the u. Okay, we already have the u, du, and the v. We can substitute them to have the arc cotangent u du equals to the u, which is the arc cotangent u, to the v, which is u, minus the integral of the b. The v we have here is u, multiplied to the du. What is our du? Du is negative 1 all over 1 plus u squared du. So we simplify this one. So arc cotangent u multiplied to u equals to u arc cotangent u plus the integral of u all over 1 plus u squared du. From this one, we are going to apply again the integration. So for the solution, we have to rewrite again the problem, no? So the arcotangent u du equals to u multiplied to the arcotangent u plus the integral of u all over 1 plus u squared du. So this one, we are going to integrate na. So solve for the integral of u all over 1 plus u squared du. For this one, we're going to let the v be equals to 1 plus u squared. So the derivative of v is equals to u du. So we have the u du equals to dv all over 2 or dv halves instead. The integral of u all over 1 plus u squared du equals to the integral of 1 over v, which is the substituted v multiplied to the du, which is equal to dv over 2. So we can factor out the constant, which is the 1/2. So we can rewrite it in 1/2 the integral of 1 over v dv. So the integral of 1 over v is simply the ln v. So 1/2 ln v plus c. So from this one, we can substitute back the v that we let earlier. So what is our v again? So our v is 1 plus u squared. So the 1/2 ln v plus c equals to 1/2 ln v, which is the 1 plus u squared, the absolute value of it, plus c. So thus, the integral of u all over u squared plus 1 du equals to 1/2 ln 1 plus u squared plus c. So we can substitute na again the solved integrated function right here to this first one, no? So the integral of arcotangent u du equals to the u arcotangent u plus integral of u all over 1 plus u squared du, which is we already solved na. So substitute it natin. So the arcotangent u equals to u multiplied to arcotangent u plus 1/2 ln the absolute value of the quantity of 1 plus u squared plus c. Therefore, the integral of the arcotangent u du equals to u arcotangent u plus 1/2 ln the absolute value of 1 plus u squared plus c is true. Right there. So that's all for this video. Thank you for listening. I hope you learned something.